Question 6, the second part of trigonometry in paper 2 is normally the trig graphs. So it normally works like this, guys. Trigonometry question 5 will be your basic, your normal trig, your general solution, your reductions, your setting up of a triangle, your identities, and then question 6 would be your graphing, and question 7 would be your 3D trig. Okay, so let's get going. We are now busy with question 6, which is trig graphs. So in the diagram, the graphs of f of x equals that and that are drawn in the interval. Okay, so just by approaching this, let's just write out our graphs here. Let's just remember what all these values do. So what does this do? This affects the amplitude. Okay, and what does this do? This is the frequency of your graphs as well as affects the period. Okay, and let's look at the next graph. We've got g of x equals minus cos of x plus 45. So what does this mean? That means that this is a reflected graph, a reflected / flipped graph about the x-axis. Okay, and then this over here means that this has been horizontally shifted, and more specifically horizontally shifted 45 degrees to the left. Remember, plus means left and minus means right. It's counterintuitive with the horizontal shifting, but when it comes to plussing and minusing for the vertical shift, plus is up and minus is down. Okay, cool. So let's get started with these questions. 6.1, let's have a look. What is the period of f? So your period, your formula for sine and cos would be 360 divided by your b value. Your b value in this case is 2, so your period for this graph would be 180. Remember, the period, guys, represents how many graphs are happening between 0 and, or how many degrees is one full graph occurring. That's what should I say. The 2 itself represents the number of graphs happening between your normal parent functions, period. So that means 2 sine graphs are happening between 0 and 360. Okay. 6.2, what do we got? Determine the range of g in the interval of 0 to 180 for a domain. Okay, so the range of g, how high and how low is g going? Well, g's amplitude hasn't been affected, has it? So g's amplitude is still 1, which means that it's going up to a high point of 1 and down to a low point of minus 1. So the interval or the range, we can either say this, we can say either or. Y is an element of square bracket minus 1 to 1, close square brackets. Or you could have also said minus 1 less than equal to y less than equal to 1. Okay, so either or, same thing, right? Okay, and that is your answer for 6.2. Let's have a look at 6.3. 6.3, determine the values of x for which, in the interval of x is an element of 0 to 180, for which, okay, now, what we're going to do here, do this in our paper 1 graphing section. When we get a question and it is f of x times g of x greater than 0, we are looking for where the product of the two y values of the graph give you a positive answer. So my scenarios here is going to be either when that one's y value is positive and that one's y value is positive, or when this one's y value is negative while this one's y value is negative, because those give you positives. Now, why am I looking for positives? Because I'm looking for something greater than 0, which is always positive. What I would do, and I'm going to extract the drawing straight from here, and I'm going to do a highlighting session. Remember what I told you in paper 1. You take your green highlighter and you highlight where your graphs are above the x-axis, so where they are positive. And then you take your pink highlighter or red and you highlight where your graphs are below the x-axis or negative. Okay, then from there, what we do is we create milestones. So my milestones are where my graphs change color. So let's use the pen again. So my graph changes color there, there, and there. And then what you do is you drop lines down to create your regions. Okay, so now you've got region 1, region 2, region 3, And that's it. We don't need a region 4. Now we're looking for where the graphs are the same colors, guys. So in my opinion, I'm going to highlight in yellow where my graphs are the same color. Do you agree with me that region 2 is where my graphs are both green? And that is it. The other two regions, if we're looking here, it's green while it's red, and it's green while it's red. So the only answer for 6.3.1 is going to be between 45. Can it equal 0? No, it can't, so we can't include it. So your two questions, set builder notation and interval notation, would be x is an element of circle bracket or soft bracket because it can't equal to 90. Or you could have said 45 less than x less than 90. Okay. Either or. Okay. And those are your answers for 6.3.1. Now we're looking for an answer for 6.3.2. Let's have a look. So 6.3.2, we're looking for where f of x plus 1 is less than or equal to 0. Okay, so f of x plus 1 means that where is my graph of f of x greater than 0? So what I'm going to do, I'm also going to do this graphically, but you can see, guys, there's no algebra with these types of questions. They're only worth 2 marks, so which indicates to you that immediately it is a visual thing. Okay, so where is f of x plus 1 less than or equal to 0? So basically negative. So what I'm going to do is I'm actually going to shift this whole graph up. So milestones wise, these are my milestones, okay, or important points of my f of x graph. If I shift it up by 1, it means that my new x-axis would be here, okay, and it means that my new graph would go up by 1. So it would be going there now, there, here, and then up to my line again. So my new sine graph would look something like this. Okay, so does that all make sense? Everything has been shifted up by 1, so that's been shifted up by 1, up by 1, up by 1, up by 1, and up by 1. Okay, now we're looking at the actual graph in question, and this question's asking us, where is the new red graph less than or equal to 0? So the only place where it's less than or equal to 0, and I'm going to highlight this in blue, is over here, guys. That's where it is less than or equal to 0. Okay, and that is in between those values. So what we need to now figure out is those points on the x-axis so that we can state our region. So something that's really cool is that they've given us A, which means that this would be our new A if I was shifting it up by 1. So that automatically allows me to say that this is 105. Okay, and what's so nice about trig graphs, guys, is that they are symmetrical, which means that the distance between this 90 and 105 is the same as the distance from 180 to this x-intercept over here. So 90 to 105 is plusing 15. So if I minus 15 from 180, it gives me 165. Okay, so that's just a little symmetrical thing and a little visual thing that you needed to see. So therefore, this answer in both set builder and interval notation, x is an element. Can it equal 0? Yes, so we can include it. So hard brackets, 105 degrees to 165 degrees. Or you could have said 105 degrees less than equal to x less than equal to 165. Okay, either or again. Either or. And that is your answer for 6.3.2. Okay, on to 6.4. Let's have a look and see what they've given us here. Okay, another graph P is defined as P of x equals minus f of x. Okay, D, K, and minus 1 lies on P. Determine the values of K in the interval of 0 is to 180. Okay. Okay, they say values. So let's have a look and see what's happening. So worth 3 marks, so a good amount of marks here. Let's have a look. Okay, so we have now taken the f of x graph and we're just putting a minus. So let's just write out p of x's function. P of x is equal to minus f of x, which is actually equal to minus 2 sine of 2x. So when we see, and this is what's going through my head, when you times your whole graph by a negative, it means that you reflected it about the x-axis. Okay, so it means it's completely been flipped. So when they're saying that D lies on k and minus 1, and we want to work out the values of k, we are then going to say that, I'm just going to redraw this graph as well so you guys can see the actual flip. Like I said, this is a very visual section. So let's see what the flip looks like. I'm going to draw my graph in yellow. So if I had to flip that graph, it's going to look like this. There we go. And it's there. And it's going to look like that. So it's basically the normal graph just being reflected about the x. And now we're wanting to know which coordinates on this new reflected graph has y values of minus 1. So what I'm going to do is I'm just going to put a dotted line like this. Now that's got a y value of minus 1. So that's 2 points on the graph that has a y value of minus 1. We also know that A has a y value of minus 1. So remember what I told you guys with regards to symmetry is that the distance between this x-intercept and this will be the same as the x-intercept from there to here. So if this is 15 degrees, then this is going to be 15 degrees. And then it's going to have the same distance from here to here, 15 degrees. So that's why it can be read. So this is going to be 75 degrees, and this is going to be 15 degrees. So now I know that this value here would be 15 and minus 1. And I know this value here would be 75 and minus 1. And the question asked me, determine the values of k in the interval that D has a y coordinate of minus 1. So there are 2 of them. So it means that we can then say, therefore, k must equal 15 degrees, or k would equal 75 degrees. Those are the x values that have y coordinates of minus 1 for the new graph. Okay, and that is how you see that. Good. 6.5, last question for this question. Let's have a look. So it's saying here, graph G is obtained when G is translated 45 degrees to the left. Determine the equation of H, write your answer in its simplest form. Okay, so G of X was minus, let's just write it out here. G of X that was given to us earlier was minus cos of X plus 45 degrees. Okay, so agreeing that plus 45 is a shift to the left. Now it's being translated a further 45 degrees to the left. So H of X would be minus cos of X plus 90. Okay, because you are shifting it further 45 degrees to the left. Now this is a co-ratio, so we can therefore simplify it and say H of X is equal to minus, what does cos of X plus 90 change into? It's the same as 90 plus X. So that one will change into minus sine of X. Therefore, your simplified version would be sine of X. Okay, great. And that is your trig graphs part of paper 2 2023. Now, obviously remembering, guys, it's a massively visual section. Very rarely will you be doing algebra or simplification here. So please know your parent functions like the back of your hand. Know what your adaptations to your formula does, amplitude, period, horizontal shift, vertical shift, and you can take it from there. Cool. On to the next question.